Okay, so we've talked previously about how to think about epsilon neighborhoods, and we've talked about how to think about open sets. So how do you think about limit points? Well, a limit point is just, we'll call this point here x, and this is going to be a limit point for a if no matter how small you draw an open interval around it, and I guess, I don't know, I just made my open interval screen, so I'll keep them with green for now. Whenever you draw any sort of a neighborhood around it, x minus epsilon, x plus epsilon, if you are guaranteed to find uh, some a sub n, some point of a in there, that means it's a limit point. Most things that you see are limit points, but not everything. In some sense, the opposite of a limit point is an isolated point. An isolated point has a property that there is some point around it. What am I doing here? Black, I guess. Right. Here's x, which is an isolated point of a. So that means that x has to actually be in a. Whereas I actually am not saying that x over here, to be a limit point, you don't have to be in the set, but an isolated point you do have to be in the set, otherwise it's not going to make sense at all. So I'm going to specify here completely that x is an a. It's an isolated point if you can draw some open interval around it for a fixed epsilon, just a single one. You only need one of them, so I'll call it epsilon naught. Where the key thing here is that if you look in here, boop, boop, there are no elements of a in this open interval. So a standard example picture would be example. Let a be equal to 0, 1, union, just a single point 2. And then if I draw a number line, here's a picture of it, 0, 1, 2, and maybe I'll just draw it in like this. And look, this 2 is far away from everything else. It is isolated. So what we can do is we can draw an open interval around it of, say, 1/2. So this would be, I don't know, 1.5, 2.5. So this is, there are no elements of a in, let's say, v epsilon will be equal to 1/2 of 2. So 2 is an isolated point. So isolated point, you think of just something way off far by itself. Let's go now again to closed set. A closed set is a set that contains all its limit points. So what that means is it has to contain all these. And the real way to think about this is, the best example is the open interval 0, 1. In fact, let's make this half open, half closed interval is not closed. Since 1 is a limit point and 1 is not an a. So that is not. Here's an example of something that is. A equal to 0, 1, the closed intervals. You know what? Here's another one. Right? That's another example of a closed set. It contains all its limit points. 2 is not a limit point, but close enough. Right? It doesn't matter because all a closed set talks about is limit points. So finally, a closure, the set A, the closure is you just take A and throw in its limit point. So the closure of 0, 1, open interval right here, would be just go A closed is equal to 0, 1.